Hello class, and welcome to section 4.2, which is about simplifying algebraic expressions. A lot of vocab going on today. We are looking at a few different pieces. The first thing we're going to do is break down expressions, and then the second thing we're going to do is simplify them. So these first four terms are going to allow us to break down the expression. The word term mathematically means each part of an algebraic expression. So we're going to break it down into each of its individual pieces so that we can see what we are working with. Coefficient means a number in front of a variable. So for example, if you have 2x, 2 is the coefficient. That tells you how many of the variable that you have. Constant is a term without a variable. So those are your plain numbers, whether they're whole numbers, integers, fractions, decimals, mixed numbers. Any sort of value without a variable attached to it is called a constant. Like terms are terms with the same variable or variables. So 2x and 5x both have an x on them, so those would be like terms. Or we could have 4ab and negative 3ab. Both of those have an a and a b, so those would be like terms. If I said 7x and 4y, those are not like terms because the variables do not match. Once we get down to simplifying our answers, simplest form means an algebraic expression that has no like terms. So every letter should only show up once in your expression. And then there's no parentheses. We learned how to get rid of parentheses yesterday when we went over that distributive property. Quick clarification that I want to make. When we are talking about like terms, they have to have the same variable. If they don't, then they're not alike. So for example, if we look at this picture and I count, there's 1, 2, 3, 4, 5, 6, 7 stars. So I'm going to say 7S. Then we've got 1, 2, 3, 4, 5, 6, 7, 8 hearts. So I would say 8H, for example. If I was asking for the total, I would add those up. Now, because these are not like terms, we can't actually add them. So I can't say that I have 15 stars because there's only 7 stars on the board. I can't say that I have 15 hearts. There's only 8 hearts on the board. I can't say that I have 15 star hearts because that would mean it's a star and a heart as one shape, which we don't have. So when we're looking at like terms, you are paying attention to the variables matching exactly. So that's just a quick visual example of why we can't put together terms that are not alike. So our first job is going to be identifying the parts of an expression. So when we're doing this, we're going to start with the terms. That's looking at each piece separately. So our first piece is 6x. There's nothing in front of it, so it's going to be a positive. Our next piece says minus 2y. What that's really saying is we're going down, or we have negative 2y's. Then we have plus x, so that's just an x. Then we have minus 5, which means a negative 5. And then we have plus 2y squared, or just positive 2y squared. So when we break down our expression and identify the terms, it's each piece listed separately, separated by commas. Now, when we're talking about coefficients, that's the numbers in front of our variables. So we've got 4 different terms with variables, so that means we need 4 coefficients. Our first term with a variable is 6x, so my coefficient is 6. My second term with a variable is negative 2y, so my coefficient is negative 2. My next term is just x. Since there's only one of them, that coefficient is 1. We could write the 1 in up when we're listing the terms. We do not have to. It's just 1x. And then our last coefficient with our our y squared is 2. Then we're looking at constants. That's numbers that don't have variables. In this case, our constant is -5. And then we're looking for like terms, so anything with matching variables. So we've got a 6x and we've got an x. So we would list 6x and x. Y and y squared are not the same variable. Reason being, if I said y is equal to 3, then y squared is 3 times 3, or 9. Those are not the same number, so that's not the same variable. So those are not a pair of like terms. So this is how it would look as we are identifying the parts of this equation. If any of them didn't exist, so let's say that -5 didn't exist for a minute, then we would have no constants. So if part of that expression doesn't exist, you just leave that particular vocab word blank. In this case, we had all of them. The last thing we're going to do is simplify. So we have this same expression where we broke down all of our pieces. To simplify, we're going to be using these like terms. Our first job is to check, are there any parentheses? The answer is no. The next part is then to combine the like terms. If I have 6 x's and I have plus 1 more x, that's going to give me 7 x's minus 2y minus 5 plus 2y squared. That would be the simplified version of that expression so that we have no like terms and no parentheses. Go ahead and identify the parts of this expression on your own. After we do that, we get the following information. And now our last step is going to be to simplify this. So go ahead and simplify on your own. Combining all 3 of those m's, which are our like terms, we get 2m plus 2. So now we're going to deal with a couple of the expressions that have the parentheses. So we've got 6y minus 3 parentheses x minus 2y. So our first goal with simplifying is to get rid of parentheses. So when we do that, we're going to use what we learned yesterday in that distributive property. So the 6y is by itself, it's not being distributed, it stays put. The -3 is what's getting distributed into the parentheses. So we've got -3 times the first part, which is x, and then we're subtracting, and then we've got -3 times the second part, which is 2y. Now we're going to want to actually do our multiplication. Again, the 6y stays put. -3 times x is -3x. Minus -3 times 2y is -6y. Simplifying a double negative is going to make a positive. So I've got 6y minus 3x plus 6y. So now my parentheses are all gone. But if you look here, I've got a 6y and another 6y. So those are like terms because they have the same variable, which is going to give me a total of 12y minus 3x. We can't put those together because the variables don't match, so that is our final expression. Go ahead and try this one on your own. We're doing 3 distributions this time, 4 times q, 4 times 8p, and 4 times 2. Once I do all that multiplication, I get the red expression. 32p and p are like terms, giving us 4q plus 33p minus 8. Last thing we're going to talk about here quickly is a word problem. So we've got Dirk scores X points during his first game of the season. That's an important piece of information. Then it says he scored 3 times as many points in the second game. So that second game, he scored 3 times as many. In the third game, he scored 6 more than in the second game. We're going to write an expression in simplest form to find his total points. So, in his first game of the year, we know that he scored X points, because that's what they tell us. In his second game, it says 3 times as many points. So we need to take this first game, which is X, and multiply by 3, which gives us 3X. In his third game, we want 6 more than in the second game. So if our second game was 3X, we need 6 more than that. Now, it's asking us to find his total points. Total meaning addition. So I've got X plus 3X plus 3X plus 6. First game, second game, third game. Go ahead and find his total on your own. Our final answer here is going to be 7X plus 6 points, because we want to make sure, since it's a word problem, we include our label. If you have questions about this or anything else from the lesson, please let me know when you get to class.